Hello, dear colleagues. I would like to thank organizing committee for the opportunity to present here our study dedicated to improvement of perspective inhibitors of SARS-CoV-2 main protease by a computational approach. The life cycle of coronavirus is as follows. 5 important processes can be distinguished as targets for blocking the virus life cycle. First, neutralization of S protein contact with the cell receptors. Second, host cell protease inhibition. Third, viral protease inhibition. Fourth, viral RNA-dependent RNA polymerase inhibition. And the fifth, blockage of the virion assembly. The most studied targets of coronavirus are its main protease and RNA polymerase. To act on the polymerase, remdesivir and molnupiravir were proposed, but their effectiveness appears to be...
presentation.
Yeah, we don't see that you don't change slides. We see just the first. Yes, thank you.
Now?
Yeah.
Oh, sorry. To act on the polymerase, remdesivir and molnupiravir were proposed, but their effectiveness appeared to be low. As examples of protease inhibitors, two most prospective compounds are known, PF231 and PF332. Both were tested in clinical trials as potential oral drugs. PF231 showed excellent inhibition ability, tolerable selectivity, but this compound has unacceptable bioavailability. It can be improved by changing the warhead moiety, but it leads to very low solubility. On the other hand, PF332 is an oral drug based on a different kind of backbone. Nevertheless, the pharmacokinetic properties of PF332 are not excellent, and this compound has a relatively low selectivity and inhibition ability. Therefore, the goal of the present study was to find a way to improve two most prospective inhibitors of Mpro by computer methods. An extensive review of in vitro studies of different inhibitors allowed to define correlations between structure and other properties. It was found that S1 and S2 residues of potential inhibitors should resemble glutamine and leucine respectively for good binding. And the backbone of a compound should be rigid and bulky at the left half for binding and selectivity. To predict pharmacokinetic properties of the compounds, a Swiss ADME online tool was used. This service allows to estimate gastrointestinal absorption and solubility of a compound, which are important for bioavailability of a drug. Comparison of approximately 50 variants of substituents constructed on the basis of the review allowed to select the compounds with improved pharmacokinetic properties. After that, molecular dynamic simulations of about 20 selected compounds were conducted using GROMACS software to obtain the structures of complexes of Mpro with design new small molecules and to assess the strength of inhibitor-protein interaction by a calculation of binding energies by MN-PBSA method. The best two were selected for this report. The average logarithm of solubility of PF231 is -3.7. Bioavailable derivative of this inhibitor with nitrile group has much worse solubility of -4.2. It is lower than that of PF332, which has -4 and is soluble barely enough. It was found that the solubility of PF231 can be possibly increased without a loss in binding ability by two alterations. Indole methoxyl can be replaced by a fluorine, which is bulky enough and more hydrophilic. And the pyrrolidone residue can be replaced by a succinimide one, which has an additional polar group. These alterations do not change the number of protein ligand contacts, but increase the average logarithm of solubility to -3.45 in the case of original warhead, and to -3.9 in the case of nitrile one. Moreover, in the case of ketone warhead, average binding energy also improves from -141 to -158 kilojoules per mole. According to MD simulations, PF332 does not form strong contacts between its left side and the corresponding pocket of the enzyme. The improved inhibitor should have more bulky left substituent while keeping the hydrophilicity. Modeling of about 10 substituents revealed that the best increase in binding energy gave a 5-atom aromatic ring linked with the next residue through an aliphatic carbon. Average binding energy of this compound was significantly improved from -132 to -180 kilojoules per mole, and the average logarithm of solubility stayed around -4. Taken together, obtained calculations allowed to design new compounds on the basis of known inhibitors with improved properties. These improved compounds after chemical synthesis could be tested in the protease inhibition assay, which was recently reported by our collaborative team. Thank you for your attention.
Thank you. So we have a question from Kunal Roy. What do you mean by drug-like compounds? Which physical-chemical properties of chemicals influence their drug-likeness?
We consider all the properties that used in Swiss IDME online tool. The most important are solubility, absorption, and I think that's all.
Okay, thank you. The next question from Dmitry Osolotkin. Compounds 1 and 2, which you show on the slides, you show measured or calculated values, and MD simulation, was it performed for covalently bound molecules or
not? The simulations were performed for non-covalent complex, and binding energies were calculated with the special script for GROMACS.
Okay, thank you. So the next question from Timur Majidov. Have you performed any work to support ability of molecular dynamic to reproduce correct binding energy? Have you performed any work to support
I see.
the ability of molecular dynamics to reproduce correct binding energy? How you validate your protocol? Did you do this?
Of course, we did perform simulations of known several compounds, not only PFs, but GC, boceprevir, telaprevir, and some other. And the binding energies of them were in the order, the same order that IC50 in vitro studies.
Okay. Dmitry Osolotkin wanted to clarify that it is well known that this compound bind covalently, and is your model relevant for these particular cases?
The binding of these compounds happens in two stages. Non-covalent binding is the first stage, and the second stage is covalent binding. So the simulations the models the simulations are of the first stage. So it is relevant at some extent.
Okay, so the next question from Dmitry Shulga. The binding energy look like those which were calculated from PBSA analysis. Is it true? So which approach?
Yes, it is PBSA method that we use.
Okay. So we don't have any further questions, so thank you.